I'm going to focus on this particular part of this example because it looks like that's where some of the mistakes had happened, of finding a corresponding point that lies on a transformed graph from an original parent function graph. So you could go about this the way that I had described in a previous video, looking at kind of a numerical approach. Or you could look at it through that transformation lens. And this was actually up a little bit further. I've got a screenshot here, so I can't manipulate the screen, but I noticed that those transformations were correctly identified. Like there's a vertical stretch of 2, there is a horizontal shift to the right 2, and a vertical shift down 1. So all of those were correctly identified. And one of the things that we could do is look at our original point and apply those transformations by first looking at any stretches and shrinks, then addressing any shifts. And the reason why is because of the order of operations. You would first multiply before you add or subtract. So that's why we do the stretch first. That's being multiplied within the function. Okay, so if it's a vertical stretch, that means it's only going to affect the vertical value. So for this point, -2, 4, to have a vertical stretch of 2 means that it will become -2 and 4 times 2, or in other words, -2, 8. That's a vertical stretch of 2 on that point. The next thing that you want to have happen, so I'm going to start with now this point, is you want to have either the horizontal shift or the vertical shift. It doesn't matter which one comes first or second, or you could do both at the same time. So let's do a vertical shift. I didn't think that through. A vertical shift of down 1. So that's going to affect, again, the y value by subtracting 1. Okay, so it's going to look like this. And that would become -2, 7. And then the last thing that we want to do, move this out of the way here. The last thing that we want to do is the horizontal shift on now this point, horizontal shift of right 2. Okay, so to be moved to the right 2 units means that it's going to affect this coordinate, this x coordinate, by adding 2. And that point now becomes 0, 7. And at this stage, all of the transformations have occurred, and so that's why you see this as the final answer, the corresponding point that lies on that graph. So what I'm doing here is I'm going to show the same thing but graphically. I have the original function and I have the transformed function with a vertical stretch, a horizontal shift, and a vertical shift in its typical parameters a, h, and k. That's what we normally see. And I included those as sliders. And then I have the original point labeled in green and the transformed point labeled in purple. And so you can see here as I stretch the function, you see what happens to the transformed point, like a stretch of 2, only multiplies the y coordinate by 2. Nothing else has changed there. If I also apply a shift of 2 units to the right, let's see, like this, now that point, well, I didn't quite go far enough, hang on, here we go. Now that point has changed again, but this time in its x coordinate. The x coordinate of -2, 2 is added to that to become 0. And then the last thing that happened was we shifted it down 1 unit. And you saw what changed there as you were shifting down was the y coordinate. So I'm going to include this file in with the video description so you can kind of play around with it to see how that one particular point is changing from the original to the transformed function.